Hello dear students, in this video I will continue with the 5th unit probability. Here I will discuss about multiplication theorem on probability, condition for independent events and solve the questions from exercise 12.6. The first 14 questions from exercise 12.6 of chapter 12 CBSE class 11 applied mathematics by Aggarwal. First we will see the multiplication theorem on probability. If A and B are two events associated with the same sample space of a random experiment, then the conditional probability of event A, given that B has already occurred, it is given by probability of A given B this is equal to probability of A intersection B upon probability of B, provided probability of B is not equal to 0. Also we know that the conditional probability of B given A, it is given by probability of A intersection B upon probability of A, where probability of A not equal to 0. Now if we take this as 1 and 2, from 1 we can write probability of A intersection B as probability of A given B into probability of B. Again provided probability of B not equal to 0, and from 2 we can write probability of A intersection B as probability of B given A into probability of A, provided probability of A not equal to 0. This way of representing probability of A intersection B as probability of A given B into probability of B are equal to probability of B given A into probability of A. This is called multiplication theorem on probability. Now moving on to independent events. If A and B are two events associated with a random experiment, then they are said to be independent if probability of A given B equal to probability of A and probability of B given A equal to probability of B. So here provided probability of B not equal to 0 and here probability of A not equal to 0. Now using multiplication theorem, using the above theorem, probability of A intersection B, it is given by probability of A given B into probability of B. Now this is equal to probability of A into probability of B. Now this probability of A intersection B, it can also be written as probability of AB. If A and B are independent, then probability of AB is probability of A into probability of B. Again this can be extended. Probability of A intersection B intersection C. If A, B and C are independent events, we have this is equal to probability of A into probability of B into probability of C. Now moving on to the exercise questions from exercise 12.6. The first one, events A and B are such that probability of A equal to half, probability of B equal to 7 by 12 and probability of not A or not B equal to 1 by 4. State whether A and B are independent. So the condition for A and B to be independent is probability of A intersection B should be equal to probability of A into probability of B. So probability of not A or not B is given, that is probability of A complement union B complement, it is given as 1 by 4. So this is nothing but probability of A intersection B the whole complement. So this is equal to 1 by 4. Therefore, probability of A intersection B, it will be 1 minus 1 by 4, which is 3 by 4. Now, probability of A into probability of B, it is equal to half into 7 by 12. So, it is 7 by 24. Now, we can see that probability of A intersection B is not equal to probability of A into probability of B. Therefore, A and B are not independent. Since probability of A intersection B not equal to probability of A into probability of B, A and B are not independent. Now the second subdivision. Let E and F be evens with probability of E equal to 3 by 5, probability of F equal to 3 by 10, and probability of E intersection F is equal to 1 by 5. Are E and F independent? Then here probability of E intersection given F is given directly. So let us find probability of E into probability of F. It is equal to 3 by 5 into 3 by 10. So this is 9 by 50. This is not equal to 1 by 5. Therefore, probability of E intersection F not equal to probability of E into probability of F. Therefore, E and F are not independent. They are again not independent. Next question, if probability of A equal to 3 by 5 and probability of B equal to 1 by 5, then find probability of A intersection B if A and B are independent evens. Now, since it is given A and B independent evens, we have probability of A intersection B equal to probability of A into probability of B. So, this is equal to 3 by 5 into 1 by 5. This is 3 by 25. The second subdivision, if A and B are even such that P of A equal to 1 by 4, P of B equal to half and P of A intersection B equal to 1 by 8. Then find probability of not A and not B. Here we can see that A and B are independent evens because probability of A intersection B is equal to probability of A into probability of B. If A and B are independent evens, then so are A complement and B complement. They are also independent evens. So we can find probability of A complement intersection B complement as probability of A complement into probability of B complement. Now let us write the steps. Given probability of A intersection B is equal to 1 by 8. Also probability of A into probability of B equal to 1 by 4 into half. This is equal to 1 by 8. This is equal to probability of A intersection B. Therefore, A and B are independent. This implies A complement and B complement are independent. There is a theorem which states this. Therefore, probability of A complement intersection B complement, it is equal to probability of A complement into probability of B complement. Now, probability of A complement will be 1 minus 1 by 4 and probability of B complement will be 1 minus half. So, this is 3 by 4 into half. So, it is 3 by 8. Next question, if A and B are two independent evens with probability of A equal to 0.3 and probability of B equal to 0.6, then find probability of A and B. So first one, it is given A and B are independent evens. So probability of A intersection B will be probability of A into probability of B. So it is 0.3 into 0.6. So this is 0.18. The second subdivision, probability of A intersection B complement. Again, since A and B are independent, A and B complement are also independent. So this is equal to probability of A into probability of B complement. So it is 0.3 into 1 minus 0.6. So it is 0.3 into 0.4. So this is 0.12. Third subdivision, probability of A or B. A or B means probability of A union B. So it is equal to probability of A plus probability of B minus probability of A intersection B. So it is equal to 0.3 plus 0.6 minus 0.18. So it is 0.72. Fourth subdivision, probability of neither A nor B. So it is probability of A complement intersection B complement. So it is probability of A complement into probability of B complement. So it is 1 minus 0.3 into 1 minus 0.6. So this is 0.7 into 0.4, which is 0.28. Next question, a die is thrown. If E is the event, the number appearing is a multiple of 3, and F be the event, the number appearing is even. Then find whether E and F are independent. So here a die is thrown and E is the event, number appearing is a multiple of 3. So E consists of the outcomes 3 and 6, and F consists of the outcomes 2, 4 and 6. We need to find whether E and F are independent. So probability of E is equal to 2 by 6, 1 by 3, and probability of F is equal to 3 by 6 half. And then E intersection F, it is equal to 6. So probability of E intersection F, it is equal to 1 by 6. Now probability of E into probability of F, it is equal to 1 by 3 into half. This is equal to 1 by 6. So probability of E intersection F is also 1 by 6, and probability of E into probability of F is also equal to 1 by 6. So from 1 and 2, probability of E intersection F is equal to probability of E into probability of F. Therefore, E and F are independent. Next question, a die marked 1, 2, 3 in red and 4, 5, 6 in green is tossed. Let A be the even, number is even, and B be the even, number is red. Are A and B independent? So A is the event, number is even. So A consists of 2, 4, 6, and B is the event, number is red. B consists of 1, 2, 3. A intersection B is equal to 2. So probability of A, it is equal to 3 by 6, which is half. Probability of B is again equal to 3 by 6, which is half. Probability of A intersection B equal to 1 by 6. Now probability of A into probability of B, it is equal to half into half, which is 1 by 4. So from 1 and 2, probability of A intersection B not equal to probability of A into probability of B. Therefore, A and B are not independent. Next question, if probability of A equal to 0.2, probability of B equal to P, probability of A union B equal to 0.6 and A and B are given to be independent, find the value of P. So this is very easy. We can use addition theorem and the condition for independent events and find P. So using addition theorem, probability of A union B equal to probability of A plus probability of B minus probability of A intersection B. Probability of A union B is 0.6, probability of A is 0.2, probability of B is P minus probability of A intersection B will be probability of A into probability of B since A and B are independent. So from this we have 0.6 minus 0.2, 0.4 equal to 0.8 P or P is equal to 0.4 upon 0.8. So this is equal to half. Next question, an urn contains 10 black and 5 white balls. 2 balls are drawn from the urn one after another without replacement. What is the probability that both balls drawn are black? So here it is given an urn contains 10 black and 5 white balls and 2 balls are drawn one after another without replacement. We need to find the probability that both balls are black. So let us take let A be the event. Both balls drawn are black. So here N of S is, there are in total 15 balls. Now 2 balls can be drawn from the 15 balls in 15 C2 ways. And N of A is the event both balls drawn are black. 2 black balls from 10 black balls can be drawn in 10 C2 ways. So probability of A is equal to N of A upon N of S. So it is 10 C2 upon 15 C2. This is 10 into 9 upon 2 whole thing by 15 into 14 upon 2. So this is equal to 3 by 7. So probability that both balls drawn are black, it is equal to 3 by 7. Next question, there are 2 red and 3 black balls in a bag. 3 balls are taken out at random from the bag. Find the probability of getting 2 red and 1 black ball or 1 red and 2 black balls. So let us take, let E1 be the event getting 2 red and 1 black ball and E2 be the event getting 1 red and 2 black ball. So we need to find probability of E1 union E2. So first let us find probability of E1. Probability of E1 will be getting 2 red and 1 black ball. So 2 red from 2 red balls can be drawn in 2 C2 ways into 1 black from 3 black balls can be drawn in 3 C1 ways. And the total number of outcomes is drawing in total, which is 3 balls from 5 balls. So upon 5 C3. So this is equal to 1 into 3 upon 5 into 4 upon 2. So this is equal to 3 by 10. And now if E2 is the event getting 1 red and 2 black ball, probability of E2 will be, now this 1 red ball from 2 red balls, it can be drawn in 2 C1 ways and 2 black ball from 3 black balls can be drawn in 3 C2 ways upon 5 C3. So this is equal to 2 into 3 upon 5 into 4 upon 2. So this is equal to 3 by 5. Now probability of E1 union E2, it is equal to, since E1 and E2 are mutually exclusive, this is equal to probability of E1 plus probability of E2. So it is 3 by 10 plus 3 by 5. So this is equal to 3 plus 6 by 10, which is 9 by 10. Next question, a bag contains 5 white, 7 red and 4 black balls. 4 balls are drawn one by one with replacement. What is the probability that none of them is white? So here the first ball is taken out and again it is replaced. Then the second ball is taken out, again it is replaced. The third ball is taken out, it is replaced, and the fourth ball is taken out and it is replaced. We need to find the probability that none of them is white. So let us take, let E1 be the event which is getting white ball in the first draw. So probability of E1 will be, we have 5 white balls among 16 balls. So probability of E1, it will be 5 by 16. And let E2 be the event getting white ball in the second draw. So again probability of E2, it will again be 5 by 16. And if we take, let E3 be the event getting white ball in the third draw, then probability of E3 will again be 5 by 16. And if we take E4 is the event getting white ball in the fourth draw, again the probability will be the same, which is 5 by 16. Now we need to find the probability that none of them is white. It means we need to find probability of E1 complement intersection E2 complement intersection E3 complement intersection E4 complement. This we need to find. Now since each of these events are independent, the intersection of all these events, the associated probability, it is equal to probability of E1 complement into probability of E2 complement into probability of E3 complement into probability of E4 complement. So this is equal to 1 minus 5 by 16 into 1 minus 5 by 16 into 1 minus 5 by 16 into 1 minus 5 by 16. So it is 1 minus 5 by 16 the whole raised to 4. So this is 11 by 16 the whole raised to 4. So this is the required probability. Next question, an urn contains 4 red and 7 blue balls. 2 balls are drawn at random with replacement. Find the probability of getting 2 red balls. So let us take, let E1 be the event which is getting first red ball and let E2 be the event which is getting second red ball. So probability of getting 2 red balls will be, first let us find probability of E1 and E2 separately. Probability of E1 will be, which is getting red ball first, it is 4 by 11. Since this is done with replacement, probability of E2, it will also be equal to 4 by 11. So probability of E1 intersection E2, since these two events are independent, it is probability of E1 into probability of E2. So it is 4 by 11 the whole square, or it is equal to 16 by 121. Now the second subdivision, probability of getting 2 blue balls. So let us take E3 be the event getting first blue ball and E2 is getting second blue ball. So probability of E3 will be 7 by 11 and probability of E4 will again be 7 by 11. Since the ball once taken, it is replaced. So it is 7 by 11 again. So probability of E3 intersection E4, it is equal to probability of E3 into probability of E4. So probability of E3 intersection E4, it is equal to 7 by 11 the whole square, which is 49 by 121. The third subdivision, probability of getting one red and one blue ball. So let us take, let E5 be the event getting a red ball and E6 be the event getting blue ball. So probability of E5 will be 4 by 11 and probability of E6 will be 7 by 11. So the required probability will be probability of E5 intersection E6 plus probability of E6 intersection E5. That is getting red ball first and then blue ball, or getting blue ball first and then red ball. So it is equal to probability of E5 into probability of E6 plus probability of E6 into probability of E5. So it is 4 by 11 into 7 by 11 plus 4 by 11 into 7 by 11. So it is 28 by 121 plus 28 by 121. This is 56 by 121. So this is the required probability. Next question. A box contains 100 tickets numbered 1 to 100. If 5 tickets are drawn successively with replacement from the box, find the probability that all the tickets bear numbers divisible by 10. So here it is given a box contains 100 tickets which is numbered 1 to 100 and 5 tickets are drawn successively with replacement. We need to find the probability that all tickets bear the number divisible by 10. So let us take, let E be the event which is getting tickets with number divisible by 10. So the outcomes favorable to E are 10, 20, 30, 40, 50, 60, 70, 80, 90 and 100. So N of E equal to 10. So probability of E equal to 10 by 100, which is 1 by 10. And here it is given 5 tickets are drawn successively with replacement. So we need to find the probability that all the tickets bear numbers divisible by 10. So the required probability will be it is getting the same event 5 times, getting the event E 5 times. So required probability is equal to 1 by 10 into 1 by 10 into 1 by 10. That is 1 by 10 the whole raised to 5. So it is 1 by 10 the whole raised to 5. So it is 0.00001. So this is the required probability. Next question. In a group of students, there are 3 boys and 3 girls. 4 students are to be selected at random from the group. Find the probability that either 3 boys and 1 girl or 3 girls and 1 boy are selected. So here there are 6 students, 3 boys and 3 girls. So we need to find this probability. So let us take, let E1 be the event selecting 3 boys and 1 girl. E2 be the event selecting 3 girls and 1 boy. So here the total number of outcomes N of S is selecting 4 students from 6 students. So it is 6C4. So probability of E1, that is selecting 3 boys and 1 girl. So 3 boys can be selected from 3 boys in 3C3 ways and 1 girl can be selected from 3 girls in 3C1 ways upon 6C4. So this is equal to 1 into 3 upon 6 into 5 by 2. So it is equal to 1 by 5. So if E2 is the event selecting 3 girls and 1 boy, we have probability of E2 equal to 3 girls can be selected from 3 girls in 3C3 ways and 1 boy can be selected from 3 boys in 3C1 ways upon 6C4. So this is again equal to So this is again 1 by 5. So the required probability is probability of E1 union E2. Since E1 and E2 are mutually exclusive, this is equal to probability of E1 plus probability of E2. So it is 1 by 5 plus 1 by 5, which is 2 by 5. Next question. X is taking up subjects mathematics, physics and chemistry in the examination. His probabilities of getting grade A in these subjects are 0.2, 0.3 and 0.5 respectively. Find the probability that he gets grade A in all subjects, grade A in no subject, grade A in 2 subjects. So we need to find each of these probability. So let us take, let E1, E2, E3 be the event getting grade A in mathematics, physics and chemistry respectively. So probability of E1 is equal to 0.2, probability of E2 is equal to 0.3 and probability of E3 is equal to 0.5. Now the first subdivision. First subdivision is it is getting grade A in all subjects. So it is probability of E1 intersection E2 intersection E3. Now since all these three events are independent, this is equal to probability of E1 into probability of E2 into probability of E3. So it is equal to 0.2 into 0.3 into 0.5. So this is equal to the second subdivision, grade A in no subject. So grade A in no subject will be probability of E1 complement intersection E2 complement intersection E3 complement. Since these three events are independent, it is equal to probability of E1 complement into probability of E2 complement into probability of E3 complement. Now this is equal to 1 minus 0.2 into 1 minus 0.3 into 1 minus 0.5. So it is equal to 0.8 into 0.7 into 0.5. And this is equal to 0.28. And then the third subdivision. Third subdivision is grade A in 2 subjects. So grade A in 2 subjects can be either in maths physics not in chemistry, maths chemistry not in physics and physics chemistry not in maths. Third the required probability is probability of E1 intersection E2 intersection E3 complement plus probability of E1 intersection E2 complement intersection E3 plus probability of E1 complement intersection E2 intersection E3. So this is equal to probability of E1 since all these events are independent into E3 complement plus probability of E1 into probability of E2 complement into probability of E3 plus probability of E1 complement into probability of E2 into probability of E3. So this is equal to probability of E1 is 0.2 into E2 is 0.3 into E3 complement is 0.5 plus probability of E1 is 0.2, probability of E2 complement is 0.7, probability of E3 is 0.5 plus probability of E1 complement is 0.8, probability of E2 is 0.3 and probability of E3 is 0.5. So this is equal to 0.03 plus 0.07 plus 0.12. So this is equal to 0.22. So this is the required probability. Next question, 2 dice are rolled once. Find the probability that the numbers on 2 dice are different. The total of numbers on the 2 dice is at least 4. So let us take, let E1 be the numbers on the 2 dice are the same. So that we can find the numbers on 2 dice are different as complement of E1. So E1 consists of 1, 1, 2, 2, 3, 3, 4, 4, 5, 5 and 6, 6. So we have n of E1 is 6, n of S is 36. So probability of E1, it will be 6 by 36, which is 1 by 6. So the required probability, numbers on the 2 dice are different. It will be 1 minus probability of E1. So it is 1 minus 1 by 6, which is 5 by 6. The next subdivision, total of numbers on the 2 dice is at least 4. So we need to find the probability that the sum is greater than or equal to 4. This can be calculated when it is equal to 1 minus probability of sum less than 4. So let us take, let E2 be the event. Numbers on the 2 dice, sum of numbers on the 2 dice is less than 4. So E2 consists of the outcomes 1, 1, 1, 2 and 2, 1. So probability of E2 will be 3 by 36 or it is 1 by 12. Therefore, the required probability is 1 minus 1 by 12, which is 11 by 12. So the probability that the total of numbers on the 2 dice is at least 4 is 11 by 12. I hope this video was useful for you. Thank you for watching.